I'm Vidya, Community and Content Specialist at PI Exchange. Welcome to our webinar on machine learning-driven demand prediction in retail. Thank you for taking time out of your busy schedules to join us today. We promise you it will be worth your time. Let me first introduce our company. PI Exchange is a deep tech company making AI accessible to everyone. Our flagship product, the AI and Analytics Engine, is a no-code end-to-end AutoML platform. With our engine, you have machine learning at your fingertips without having to write a single line of code. This is particularly helpful for users who may not have the technical expertise or any coding knowledge, but still want to use machine learning. For today's session, I'm joined by one of our expert data scientists, Dr. Kathy Sarafrazi. She will be walking you through how you can build a machine learning model to predict demand using the AI and Analytics Engine. So, what is the AI and Analytics Engine? The engine takes you from raw data all the way to model deployment without any coding necessary. It streamlines the traditional end-to-end machine learning process and empowers anyone, even non-technical users from any industry, to create and deploy their own machine learning models to get predictions from. Before we jump in, I would like to find out, what industry is your organization in? You can answer this question in the poll tab on the right-hand sidebar. So, the ability to accurately predict demand is very helpful for anyone in the retail, e-commerce, hospitality, or supply chain industry. That's it, really anyone from any industry that has to plan around demand would find demand prediction can aid in their planning. A study by McKinsey estimated that the potential annual value of AI for the retail industry to be between $400 and $800 billion globally. This is where the retail industry is headed, using AI ML in their processes. So here's my next question. Some customers tend to abandon their purchases due to product stockouts. What percentage of a retailer's sales revenue do you think is lost to this? You can answer this question on the right-hand sidebar. Let me reveal the answer. The answer is 4%. 4% of your sales revenue is lost to this, not to mention the other significant losses that occur with improper demand planning. This can be fixed. Machine learning can help you fix this. By using machine learning, you can analyze various internal and external variables that impact demand. For example, inventory levels, market trends, or seasonality. With input from various different sources, you can take into account more data, which ultimately leads to a more accurate demand prediction. And with accurate demand prediction, you're able to maintain adequate stock levels. And of course, with the right stock levels, you can easily avoid stockouts and the losses associated with them. So my next question is, what percentage of stockouts, in your opinion, are due to improper replenishing practices, like ordering too late, generating inaccurate demand predictions, or mismanaging inventory? The answer is 72%. 72% of stockouts are due to improper replenishing practices. There is great room for improvement here by simply generating more accurate demand predictions using machine learning. With proper demand prediction, you can optimize your inventory and pricing decisions to essentially maximize profits. Okay, so now let's get into the data set that we will be using for the demonstration. We will be using a publicly available data set from Kaggle that looks at transactions in a store. We will be using this to predict demand. And for those of you who are just joining us, welcome to the webinar. We are just about to start the demonstration in a bit. If you have any questions or if you have a specific use case you would like to have some help with, you can book a free demo with our team of experts. You'll find the link to book a demo with us in the bottom left-hand corner of your screen. Dr. Kathy Sarafrazi will now walk you through the use case. Over to you, Kathy.
So first, we're going to start in the data ingestion step. In this step, we will import our data and upload it to the platform. Once our data has been uploaded, we will move on to preparing our data set for our machine learning model. So the goal of our machine learning model in this demo is going to be to predict the amount of sales of different merchandises that we have in our data set. And to do that, we need to do some pre-processing on our data. So any sort of data cleaning, data processing that we might need, or data transformation will go into this stage. When our data is ready, we will select the columns that we want to use as features. These are the columns that are the inputs to our model, and we specify our target column, which is the column that we want to predict. After that, we can select from the list of the models that are available on the engine which ones we want to train, and we will train them and evaluate and compare these models to make a decision which one is more suitable for our application. And when we have chosen the model we want, we can deploy it and use it in our application. Okay, I'm going to get started on the engine. This is the data set that we will be using today. As you can see, we have different dates, and we have different product types. This is a data set of different apparels, garments that were sold in a store. We have the total number of sales for each day, and some features of that specific product, like the type of product, the price, the brand, and so on. But we'll get into more details of the data set later. And our goal here is basically to build a model that can predict the cost of the sales of each product for each day. And our end goal is to use that model to predict how much each item would sell in the future based off of the model that we have. So this is where we're headed. Now let's get started on our homepage in the engine. I'm going to start by creating a new project. I'll name it Sales Prediction. Create. I'm going to add my data set. You can see I can select from a list of different databases, or I can upload the file directly. So I'm going to upload my file directly. And I'm curious to know, so here we're using this data set on retail sales. What type of data set do you have? Do you have any data set that you think could be suitable for this demand prediction use case? If yes, I'd be curious to know in the poll section. And now I'm curious to know what your goal is from demand prediction. So here our goal, like I mentioned, was to predict sales, which we can use to predict demand. But do you have any other goals from demand prediction? All right, our data set is ready here as well. So we can see the preview of our data set here. We have the date column, the ID, and so on. We can make sure that everything has been read correctly. And if we're satisfied, you can click next. The engine is showing me the schema that it has detected for this data set. So I can see the column types that were automatically detected. For example, the price has been automatically detected as numeric, and so on. If I'm not happy with any of these, I can change them to the correct type. But here I'm just going to create the data set and keep everything to the default. Throughout the demo, some of the steps might take a few seconds to complete, so I'll just jump to the end result. This should not take even a minute, but to save us some time, let's go to the end result, which will be this. Once the data has been uploaded, the engine is asking us if we want to create a new data wrangling recipe, or we want to process our data using a recipe that we already have. So if you remember our steps on the engine, this was the second step, which is the data wrangling. In our recipe, we will include all of the actions that we want to apply to our data set to make it machine learning model ready. Any sort of cleaning or transformation will go into this recipe. And the benefit of it is that once you have created a recipe, you won't have to repeat all of those steps manually. When you have new data coming in, you can use your recipe to process the data, and it will be very quick. Here, I don't have a recipe, so let's create a new one. Let's say new sales recipe and create. The first time you create a recipe, it might take a couple of minutes to start, but from that point forward, it will load very fast. I already have a recipe started here, so I'm going to go ahead and use that one. On the left-hand side here, I have a more thorough preview of my data set. I can have a look at the first few rows of the data set and examine the columns more in detail. So like I said, we have some information on our product, the price, the SKU, which is the type of the product that we have, the SKU name, the gender that product is geared towards, category. We have different types of garments here. We have the brands, what collection it's from, and so on. You can have a look at the different features, and our goal is to predict the sales of this item at any given day, and we can use the sales to predict our demand. On the right hand side, I have my recipe panel. The first step is the suggestions that the engine is making for processing this data, so I can use this suggestion as the first step for my data processing. You can see, for example, it's suggesting that I convert the date column into datetime type. If I want to see why this suggestion was made, I can take a look at the analysis here. So it looks like the strings that are in this column are in the datetime format. So that's why this recommendation has been made. It's a correct recommendation. So I'm going to add it to my recipe by clicking that plus button. And you can see in my recipe tab, now the first step is to convert the date column into datetime tab. And if I go back, my date column is now datetime type. Before it was of text type, like this column, for example. But now it has changed the type. You don't have to just use the suggestions. We have a very wide range of actions in our action catalog that you can use to clean, process different types of data. You can fill missing values if you need to do some sort of interpolation, binning. If you're dealing with time series data, we have actions for that, datetime data, and so on. Here, I'm just gonna use one more action, and for that, I'm going to create a new column using a formula. So what I want to do is, you can see we have the price column here, which is basically the ratio of the sale price to the cost of the product. So we have, for example, for this one, 1.8. This means we're selling this at 80% profit. I want to calculate the actual sale price. So I'm going to name the output column sale price, and this is going to be equal to the cost multiplied by my price. I can easily input the column names here. You can see there it's suggesting an autofill, so I could say price multiplied by cost. So very easy to input the formula, similar to what we have in Excel, but here the benefit is that you can use it to apply formulas to very big data sets. So if you have worked with Excel, I'm sure you know that it's very limited in the amount of data that it can handle. But here we can work with big data, but we can also have that ease of inputting formulas and manipulating the data. We can use the formulas to create new columns, transform columns, or even filter the rows based off of formulas. All right, I'm happy with my data wrangling recipe for now. So what I'm going to do is I'm going to commit the actions. Once the actions have been committed, I can't remove them or edit them anymore. And when the committing has finished, I can go ahead and finalize the recipe and save the output to a new data set. This would take, I'd say, around a minute to finish, but just to save us time, I'm finalizing this. I'm calling it per prices output. This will be the name of my output data set. So this is my processed data set. I can download it if I want to. So if I want to use it for some kind of external use in another dashboard or to create some visualizations or reports, I can download it here. I can have a look at the analysis for this data set. I can see the distribution of different values in the data set. So for example, the sales price column that we created, this is the distribution of the prices. We have items from $30 to $170. And you can see most of the items are, for example, between this price range. If we want to have a look at the output data again, we can have a look here. And so on. Okay. But here I'm just going to use this output to create a machine learning model. And to do that, I'm going to create an app from here. So my app name is going to be Sales Prediction App. My data is going to be the one we just created. It's a prediction task. Our target column is going to be sales. Next. And I'm going to keep the configuration to default. Okay, my app is being processed here. Once it's finished processing, we can use it to create our model. I already have one that's been processed, so we can use this. Here, for our model creation, we have 3 steps. The first step is going to be creating our feature sets. So as you remember, these are going to be the input columns for our model. Then we can select the model we want to train and train it. And at the end, we can deploy the model that we want. So let's start by creating our feature set. We'll name it Features Sale. Next. And here I can see the list of columns included in the data set. And based on my domain knowledge, I can choose which ones I want to include in the model. Here we have date, we have ID. I don't want to use these in the model. It doesn't really make sense. ID that has no correlation with the sale, obviously. We have the SKU ID. So I'm going to select this because this is the product type. The price, I'm going to select this. I have the SKU name. I don't want to use this because this basically has a one-to-one relationship with the SKU ID. For each ID, we have one name. So let's not select this, or we could use the name and not the ID. We have the gender. We want this category, brand, collection, price tier, style. We have cost. We have year, month, day of week. Day of month I'm not going to use. You can use if you want to. And we have a week here. Okay, so let's create a feature set. It's being processed. This would take like a minute to finish, but I'm just going to use this other feature set that I have ready. I can use it to train my model. Okay, so our feature set is going to be this one, and we can now see the list of models that are available on the engines. We have a large variety of models on the engine, both CPU-based and GPU-based. So based on your data and the size of it, you can choose whether you want to use GPU or not. If you're not sure which one is going to perform best or which one to train, the engine helps you. If you select a model, you can see what the engine is predicting the performance for this model to be and what it's predicting the training time and prediction time to be. So if I choose, for example, these two, I can compare them and see which one performs better, which one's going to train faster, which one will have faster predictions, and so on. So based off of this information, I can choose which ones I want to train. And unlike other platforms that basically run a portion of the data through all of the models to give you this information, our platform uses AI to predict these values. So it saves you some amount of computation. So let's say I want to train these two. I can click next here. I'm going to keep the configuration to default. If you're a more advanced machine learning user, you can configure the model parameters. And my models are being trained in parallel here. You can see I have the feature set information, the type of the model. And in machine learning and data science, it's very common to train different models on different feature sets. Here, because we're training in parallel, we can train multiple models and see their performances and compare them. And that will save us a good amount of time being able to train in parallel. I already have some models that have been trained here. So I'm just going to go to the model leaderboard to see how each one performed. Here I have on the top a summary of how different models perform. So we can see the one with the highest prediction quality is light GBM regression. The one with the shortest prediction time is XGBoost regression. And for the shortest training time, I have the random forest. So based off of this information, and if I want to see more details, I have the list for all models here and the values down here. I can choose which one I want to use and deploy it. So for example, if you compare these two, this one has higher accuracy, but this one has a lower prediction time. So if you have an application that you need really fast predictions, you can decide, is a half a second of a prediction time worth it to lose 1% of prediction quality or not? And based off of that, decide which one you want to deploy. Let's say we want to use the one with the highest accuracy, with the highest prediction quality. We can click here and we can see more details on that model here. So we have the prediction quality, error, percentage error. We can see more details from the performance of the model in this tab. Let's say we're happy with this model and we want to use it. What's the next step? It's going to be to deploy the model. Deploy it. Are you satisfied? Yes, I'm going to deploy it. This is going to be my model. You can deploy it to your on-site environment if you have one. But here I'm going to deploy to the API Exchange Cloud, creating a new endpoint for it, and deploy. Once my deployment is ready, I can use the endpoint that we created to call the model and get predictions from the model. So let's say if a new set of data comes in, I could either use the platform's batch prediction. I could upload the data here and get prediction for it. Or if I have a dashboard in place, I have a system in place, I could actually use that to call the model using the endpoint and get the predictions and feed the predictions into my dashboard to calculate whatever I need. Let's say if I want to calculate demand based off of these predictions, I can. If I want to make decisions on what to purchase, how many items to order, I can use that. And we could also use the predictions for other goals as well. All right, so once we have our deployments ready, we can also use the explainability tab in the model to see how different values, changing the different features would affect our output. Here, for example, I have these values for my input. I have this price point, the gender, and so on, the other features of the product. One use of this model would be to predict how much we would sell if we change the price. So let's say you have an item coming in, you want to see what's the optimal price that I can sell this for. For example, if I sell this item for 5 times the price that we bought it for and predict the amount sold, then we can compare it to what if we sell it for the price that we got it for example, or other prices. And we can compare these prices to see which one gives us the most amount of profit. Okay, so for 5 times the price, you can see I'm selling 295. So let's add this to comparison. If we sell it at 100% margin, then we are selling more. And we could, I already have some other items in the comparison. That's why I can add any more, but we can compare them if we want. You can see for different prices. So if I sell it for 2.3, I'm going to sell 421. If I sell it for 5 times the price, I'm selling 300 something. So my sales went down by like 100. If I sell it for the price that we bought it in at basically break even, we have 1,700. We have 1,700 units in sell. So we can see how changing the price would affect our sale. You could potentially see, let's say if I put our item on sale, we deduct 20%. How would that affect our sale and profit? So you could use this model in that fashion to see, is, for example, reducing the price worth it, or is it actually going to bring down our profit? Something else that we could actually do with these, with such a model, is that, let's say we have our price set, we have a product coming in, we want to predict how much we're going to sell in future. So let's say we're now in July. I want to see how much I'm going to sell in 3 months, so that I know how much I should order. So I'm gonna change the month here, and you can see it's around the same amount. So we could change the date here to see how much we could order in advance. We could change the price to choose an optimal price for our garments, and so on. So the possibilities with such a model are infinite. And that's it for our demo. And I'm curious to know, now that we have gone through the whole process on the engine, from data ingestion to creating this model that you can see we can use for different applications, what's holding you or your company back from integrating something like this into your process?
Thank you, Kathy, for taking us through the demo and showing us how to predict demand. To summarize, you can see that by simply using the data that you already have on your customers, you can build your own predictive models to start predicting demand. All this is done in the AI and analytics engine with no code necessary on just one single platform. Predicting accurate demand allows you to accurately plan stock and inventory replenishment. This ultimately leads to significant cost savings as retailers avoid the drawbacks of under or overstocking. All right, I believe we've come to the end of our session. Thank you very much for joining us today. We hope you've gotten something valuable out of this event and are ready to start your journey on machine learning-driven data prediction. Let's continue this conversation on our Slack channel. We'll be happy to answer any and all your questions. If you have a specific use case in mind, or you would like more specific help, we'd be happy to help talk you through a demo. Simply book a demo from the link on the left-hand side. And alternatively, if you're ready to take the engine for a spin, you can trial the engine free for 2 weeks. Thank you, everyone. Have a wonderful rest of the week.